All right, we have a sign here hanging by two ropes from a ceiling. The ropes have theta1 and theta2 angles with respect to the ceiling and have a tension of T1 and T2. T1, theta1, and theta2 are given in the problem. We're asked to solve for the mass of the sign and the tension in 2. The tricky part here, I think, is just identifying where to draw your force diagram, which will end up being right here. You're going to want to draw the forces surrounding just that point of connection. It'll be the ropes, tension 1 and tension 2, and your sign. Turn that here. As you can see, theta 1 and theta 2 just kind of get put into this position here. You can see in the first diagram, these are actually alternate interior angles made with the ceiling, as so. So you get this diagram here. And here it's just a matter of balancing the forces as a common statics problem. So your forces in X and forces in Y have to balance. So if you can draw your triangles here, you'll see very quickly that T1 cosine theta 1 is opposite, pointing this way, the tension in this rope here. So it's equal to T2 cosine theta 2. Now I set them equal to each other because they're opposite. They're the only force acting in the X direction, so they'll have to be equal to each other in order for this spot to stay static, as in a hanging sign. With this, you'll be able to calculate your tension 2, because we were given T1, theta 1, and theta 2. T2 ends up being 189.28 newtons. Don't forget your units, because it'll come as a surprise in a minute. Then again, in the vertical direction, you'll have the same sort of problem. So your forces are pointing up and out in the ropes, and the force of the sign is pulling down. So you have T1, and then it's going to be sines. Remember SOHCAHTOA. And then this is the tension in 2 is pointing in the same direction. So we're assuming upward is positive. And then this is going to be equals, again, this is a static problem, the force and the sign downward. Now we have all of these. We can find the force on this point by the sign as 396.9 newtons. Now, if we remember back on the problem, we were asked to find the mass of the sign, which would be in kilograms in the SI system. So we will need to divide this by our gravitational constant G to get a mass of the sign, which is equal to 40.46 kilograms. Yeah, so if we look back, you'll see here, their force, we have a tension 1 up this way, 320 newtons, and then T2 ends up being a little bit smaller, and as you can imagine, this is because it's a little bit more vertical. This rope is having to pull a little bit harder because it's so much shallower. This angle is much smaller, so it's having to pull a little bit harder to make an equal force here. And you end up with a 40.46 kilogram sign and tension in rope 2 being 189 newtons.